Hello, welcome to the CEO dg&la YouTube channel.
In this video, we'll be discussing Leetcode weekly contest solution. So we have one of the problems from yesterday's contest, and I'll be explaining you the solution of it. Let's get started. Here is a problem statement. So it is 5881st problem. That is, find the maximum difference between increasing elements. So it is as simple as the problem statement. Let's see the description. So we are given a zero index integer array called nums, the variable, and it is of size n. We need to find the maximum difference between nums of I and nums of j. So we have the absolute difference, which means that we can directly do nums of j minus nums of I. So the greater one minus the smaller one, such that 0 is less than or equals to I less than or equals to j less than I, which means that the index of I must always be less than j, and it must lie between 0 and 10. And also, nums of I must be less than nums of j. So it's the obvious thing from the difference we understood above. We need to return the maximum difference. So if no such int exists, so we'll be returning -1. So that's the problem statement. And let's see some examples now. So the example one, we have nums equals to 7154. So let's see how it goes. For suppose if we start with 7 and 1. So here we can't take 7 and 1 because as we earlier saw the problem statement, the number in the left hand side must be less than the number in the right hand side, which means that it must be in ascending order. Left must always be less than right. But here we have the rules. 7 is greater than 1, which means that left is greater than right. So this one we can't consider. Let's get to the next one. Let's see from 1 to 5. So 1 and 5, 1 minus 5. So we can consider this because 1 is less than 5 and we need to do the difference as 5 minus 1 because we took it as nums of j, that is the right hand side one, and nums of I, the left hand side one. So nums of j minus nums of I will give 5 minus 1, that is 4. And this will be the maximum difference because if we consider the next one, 5 minus 4, obviously we can't do that because it's not in ascending order, which means that the left hand side is not less than the right hand side. So the only possible answer we can take is 1 and 5, which gives 5 minus 1 equals to 4. The second example now, 9432. So we have one more array in the same order, like it is in descending order. So by seeing it, just we can say that this is not the required case because as I mentioned earlier, just see if the number, any number, like pair of numbers are in ascending order so that we can get the maximum difference between those two numbers. But none of the elements here are in ascending order, which means that we only have to return -1. That's the second example. The third one, let's see once again. So we have 1, 5. Let's start with 1 and 5. So we can consider 1 and 5 in ascending order. Left is less than right. So we take it as j minus I, which means that 5 minus 1 gives 4. So we got one valid answer, but let's see if this will be remained as the maximum difference. Next one, 5 minus 2. So we can't consider 5 and 2. Next, 2 and 10. Let's see. So 2 and 10 we can consider. So 10 minus 2 gives 8. So when we compared between adjacent numbers, we got two maximum differences, that is 4 and 8. So between these two, 8 is correct. But we shouldn't not only see like the consecutive numbers. We have to iterate between the first and the whole set of it. So in such case, I'll be just simplifying this. Now, just let's see what is the minimum number and the maximum number. So in this, yeah. So in this, we have the minimum number as 1 and the maximum number as 10. So we can directly consider these two. And are they making a valid pair? Yes. Because 1 is in the index of 0 and 10 is at the index 3. So I is less than j. It is a valid pair. So the difference, it's easy. 10 minus 1. That is 9. So now we got 9 as our output. So it is obviously greater than 4 and 8. So this will be our maximum difference. And the output will be written as 9. So that's how the example goes. Now let's look at some of the constraints. We have the constraints. So n equals to nums of length, that is the length of the array. 2 less than or equals to n less than or equals to 1000. So the length of the array doesn't go beyond 1000 and is not less than 2 because we need to compare two numbers to get the difference. So obviously it must not be less than 2. And the number I, that is the integers in the array, will lie between 1 and 101. So these are some of the constraints which will be useful when dealing with corner cases or edge cases. So we need to keep that in mind. So now, as we have understood the whole problem, along with some examples and constraints, let's dig deep into the solution. So here is the Python solution. This is also a simple one. The Leetcode platform, so we don't have to deal with first two because these will be given by default. We just have to consider the variables that are passed as the parameters, that is, here we have nums. So let's see how we can deal with the problem. So we have considered result, that is array of result. So in order to, this is the line of code. So we are storing all the differences between the numbers in result. So we'll have the difference of the numbers in this. So it's just a diff array or list in Python. And now, so the simple one, like the first thought we get is to iterate. Like we need to do the iteration from first element to the end of the array. So we do that using two loops so that we could compare easily between I and j. So I loop goes from len of nums minus 1. That is, so if we consider nums as, so let's see what the question we can say. Let's suppose it as 3, 4. So let's take this array. So we'll be iterating I value from 0 to then of nums minus 1, which means that the length of the array will be 4. Nums minus 1 gives 3. As in the Python loop, we'll be iterating only till 2. Like for suppose in this list. So we'll be taking from 0, 1, 2 only. The 3 will be excluded for index I. I will be till 0, 2. Now let's see where j goes. So j goes from I plus 1 to len of 1, which means that whenever we take 0, suppose if in the first iteration, if we take the third number, which means the integer with index 0, j will be from 1, which means it will be comparing 3 with 4, 3 with 5, and 3 with 9, and the iteration goes on. So we need to consider from, j will be considering from I plus 1. So we can't just start with the same index, because if we start with the same index as like I, it will be 0 anyways, because the same number minus number will give 0. So whenever we consider j, it must be I plus 1, which means the adjacent number. So it goes from I plus 1 to, we'll be going now till the end of the array, which means that len of nums, which means till 4. So it will be iterating till 3, the index 3, till the end of the array. So that's how the loop go on. So that's how the loops go on. Now let's see the condition. So this is the logic, that is the heart of the problem. So if nums of I is less than j, which means that this is the constraint we took, like the first element must be less than the second element. So that is what we are given. Then we are storing that nums of j first in n and nums of I in n. So let's suppose we are iterating through 0 first, like I is 0 and j will be 1. So we are storing nums of j, which means 4, we are storing it in j. So in the first iteration, we get m as 4, and n will be nums of I, which means 3. And what now? We are appending the difference between 4 and 3, that is 4 minus 3, which we get, that is 1. We are storing this in resultant list, that is the one we considered here. So the difference goes to the RES array. So it will be something like 1 only per num. Okay, yes. And so this is the logic behind the solution. But if this doesn't happen, like we have some cases where the first element is not less than the second element. Let's suppose we have 1 here instead of 9. So here we can see that in this iteration, 5 minus 1. So that is how we are getting, which is not a valid pair. So in such cases, we are directly appending only minus 1 in such case. So whenever the if statement fails, the else statement comes into the picture. So that's the simple logic. And now let's see the direct solution. Like we have understood the logic for the array we took, that is 3, 4, 5, 9. If we take a number that is base number 3 and the highest number 9. We have the valid pair, that is I and j. So 3 and 9, which means I is less than j and they become a valid pair. Now we are storing j value, that is nonce of j in m, which means we'll get 9 here in one of the iterations and we'll get 3 here for n, and the difference between 9 minus 3 is 6. That will be stored in resultant. So at some point, the resultant will be stored with some more numbers here with many other iterations. And we'll be getting 6. So this will be our resultant n. So the final touch to the solution. So we are storing all the differences in the resultant, but we need only one solution for our problem. So what we'll be doing? As we need the maximum difference, we just have to consider the maximum of this resultant array. So if we take the maximum of the resultant array, that will be a solution. So which we wrote it after the logic. So this will give, this will return the maximum of resultant to the function, and we'll be getting the final solution. So this is how a simple problem of Python, that is finding the maximum difference, goes. Hope you liked the video and understood the solution. So if you have any doubts, do mention in the comments, and we are also open for any kind of solutions. Hope you enjoyed the video and keep on doing the coding.
Dhanyavad. Thank you. If you like this video, do like, subscribe and share. See you in the next one. Bye bye.